All right, we're going to go ahead and get started. The next talk is Map Libre and the future of vector tiles. And who better to speak about that than Yuri, co-founder of Map Libre. Give it up.
Hello. Good to see everyone here. Today, well, usually I do fun presentations, a few, like live demos. Today, the most challenging and exciting demo will be, will the internet work? So I hope it will, but it is a challenge. So today, the internet is on demo. Anyway, my name is Yuri. One of my claims to fame is, or infamous, is Map Libre. And I'm going to talk about that first, and then I'll cover some of the vector tiles and where I see we can go from there. So what is a Map Libre project? The idea was to form an organization, a nonprofit, community-governed, community-driven, corporate-sponsored, or individual-sponsored, volunteered, to go all the way from data bits to pixels and everything in between. And we're talking about data generation, data packaging, slicing, dicing, visualizing, interacting, and many other things in between. We're on that path, and hopefully one day we'll take over the world. It started as a fork of Mapbox GJS, and very grateful to all the amazing technology Mapbox has contributed. We have the web native as the two main heads of this dragon, to visualize data on web and on the native Android, iOS, and platforms. We have a number of plugins. We have a number of side projects that are, such as Martin, the tile server, and many others. Open licensed. And yes, we do accept donations. So the very quick bragging thing, how did it all get started, i.e. how to cause chaos in a few Twitters. License is everything. Map Libre, Mapbox at one point committed yet another GitHub commit, saying that license is no longer what it used to be. Surprise. So I immediately tweeted that, how about we start the Map Libre as a fork. 8 minutes later, CEO of Mapbox replied, "We love open source." To which I said that, yes, well, we love you too, but we need to go open source. And that's how it started. A few people contacted me, and that's where Map Tyler, Steady Map, and a few other interested folks got together. We sat and decided on the path forward and how we can bring community together. Forking is very easy. As anyone who used GitHub knows, you can just click a button and, oh my God, you have a fork. And then you have to maintain it and merge the breaking changes and defork it somehow, and that's a pain. So community is by far the most important and most valuable thing anything like this can have. That's, one of the reasons I speak here, because, oh my God, it's a community that I care about. Forking is easy. So we had a meeting summary saying, yes, let's work on it. At the time, it was just Map Libre GJS. And later, it kind of turned into TypeScript. I'm pretty sure Mapbox would love to use this technology by now. So we have 4 core projects. And before each one of these lectures, the very first thing I do is just go through the numbers and try to update them. Yeah, it's, kind of pat on your own back type of exercise. And so far, the numbers have not been going down, so that's a good thing. Some of them have been going up pretty rapidly. That's also a very good thing. And some of them we should work. Anyway, native, the C++ library, actively developed. Lots of corporate backing for that one. There's a lot of interest in Android and iOS apps to support it, especially with Apple switching away from OpenGL to Metal. There's been a lot of work in that department. Web, well, web is web. Everyone knows it. Everyone loves it. Martin, my personal pet project that came to us from another company that donated to us, and it's tile server, and that supports Postgres, and it supports PM tiles and MB tiles, and it can do sprite serving, and it can do very soon font serving, you know, like Map Libre style font serving. And last but not least, a research project that I'll talk about in a second. Open governance, every year we get re-elected. Hopefully, I'll continue serving on the board for a while. But we have a technical committee that drives the projects forward from the technology perspective. We do not want this to be a corporation running a open source project, because corporation goals change. The idea of open governance is the goals are always aligned with the community. We have amazing sponsors. AWS and Meta have been heavily involved with us since the beginning, really supporting us and helping us get on our feet. We have a number of amazing silver sponsors and a huge number of individual donors, which I'm grateful, very grateful to. We have a big community, lots of people from all over the world. Yes, even though the world is kind of square, I mean, we all know WebMarketer is, well, I'm going to be talking about that too later, but you know, in reality, it's kind of circular and spherical. The vision, we have tons of efforts to do the meta migration, and that's pretty much done thanks to amazing work. There's actually, they're right there. Did most of the supporting. We want to do the globe view, you know, zoom out and actually see the sphere rather than square all the way up. Hill shading, fonts, and many other things. Martin, that's, as I said, my personal favorite. Allows you to do tiles, and this was supposed to be a demo. This allows custom tiling on the fly. So if you have a whole bunch of rapidly changing data and you want to generate vector tiles on the fly as you go, together with some additional querying, like where a user configures that, oh, I just want this portion of the data or in this format or whatever, Martin can handle that for you. Written in Rust, extremely fast, well, you know, the whole 9 yards. 3D or not 3D, this is the fun hill shading. Surprisingly, it works. So good so far? Yeah, it's, okay, this is where you're supposed to say, ooh. I mean, I love hill shading. It's always wonderful. So when we were able to add support for that, that was really, really nice. And the clickers, oh, there we go. Wait, did I get it right? Yeah, I did get it. One of my goals is to keep this whole thing steady, stable. I mean, that's the requirement. That's the expectation of a big project like ours. Tomorrow should not have too many breaking changes. We all know how lovely it is to upgrade your code because someone decided to rename a function. I'm guilty of that myself. I rename functions all the time. Well, people don't like that. People prefer to keep the same function names even if they're misspelled. So stability is the one aspect. But on the other hand, we have this two-headed dragon, the native C++ code and the JavaScript / TypeScript that essentially do the same thing but have their own set of bugs. You know, we cultivate two different petri dishes of bugs. So it's ideal that we can combine all these bugs together into one project that can actually output data, output code for both web, i.e. WebAssembly, and all the native implementations. And so far, Rust has been quite interesting. And that's where Map Libre RS comes in. But overall, we want the stack to be concise and unified. And that's where we want to go from generation. And the Planet Tiler by Mike from, I keep forgetting his last name, horrible of me, is able to generate all of OpenStreetMap tiles on a laptop in like a few hours or on a beefy machine in 30 minutes. I mean, it's ridiculous. You take this entire OSM dump and you convert it to Z14 in 35 minutes or so. That's kind of impressive. with a single process, no database, nothing. I would love to integrate more connection with that process. Serve tiles, Martin. Render tiles, the three-headed dragons that I was talking about. Plugins, standards. So that's Map Libre RS. This is what it's capable of already. Oh my God, it can draw polygons. Fonts is kind of more difficult, so that's in the future. I'm going to embarrass myself again here. I have no way of pronouncing this correctly, so I'm just not even going to try. But this is a volcano. And the eruption of that volcano was modeled using PM tiles and 3D terrain and to see what you can do. And we got this demo, and there's a link at the top. I'll publish all the slides on my Twitter, so it's, well, you can watch it. CloudBuddy, another demo project where they were able to use DeckGL with all sorts of advanced visualization on top of Map Libre to create essentially a very helpful weather demo. Computer, oh, there we go. Contour maps, another fun project. This is like a client-side contour tracing where you're just able to visualize contours on a map for a number of useful use cases with very simple code. So this is our aspirations. Roadmap, we've covered a lot of ground already. We got the community going, we got the main projects going, everything is wonderful, we're moving forward, yay. We have a lot of more advanced goals. Deal with native, try to get native on par with WebGL version. Possibly add other projections. People, especially from government, they do not accept Web Mercator. I wonder why. I mean, I prefer it. I think it's perfect. The world should be nice and neat. Single code base, other ideas. So we want full-time to engage the project. We want continuous employment to keep the knowledge going and to rapidly reply to your requests for features, your request for ideas. Your pull request should be merged, you know? Sometimes when you spend all this time submitting a pull request, someone should look at it and say, meh, or say something, oh, okay, that sounds good, but you need to fix A, B, and C. And that requires someone's dedication. And volunteer work can only get you this far. So that's why we constantly do the various donation efforts in order to sustain us as a beneficial product for all of you guys. That's the whole idea. Rust is my personal religion. I'm not going to go into that. Font support is also another thing. So currently, it's all separate glyph-oriented visualizations. Think Latin scripts, Cyrillic scripts, Hebrew, Arabic, even though has ligatures, it's still fairly simple to do. But more complex fonts, they require much more elaborate handling. So we would love to support all that. So now we're moving to the MVT. I mean, everyone knows what MVT stands for. It's a map vector tile, right? And we love it. We use it all the time. And yet, we can do so much better with it. They're awesome, but they were created for a very simple use case, and they can do more than that. I work for a car company, Rivian, and we're actually experimenting with all sorts of advanced usages for not just visualization, and it works quite well. The main usefulness of MVT is that it's ubiquitous. It works for everything. You can visualize it, you can process it, you can generate it, you can parse it. It's all available, very simple. But it's extremely slow. It's only 2D. You cannot use it very efficiently or effectively for non-2D cases. There's limited data types, and it's hard to extend to other use cases. So the new use cases. What do we want to use for MVT? One of them is the multiple M values. Anyone familiar with PostGIS or OGC? I mean, M value is like this magical value. That's what M stands for. That gets attached to essentially each vertice along your polyline. You can measure elevation along your route. You can measure the width of the road along your route. You can measure for each vertice at what time it was taken. So there's all these different M values that we would like to store in addition to the simple 2D geometry. Well, we want to abandon the web Mercator. It's simply not very convenient to use in many cases, especially around polar circles. For some reason, I mean, we kind of assume that no one would go there for anything useful, but it turns out they're kind of useful to many use cases. Valhalla and routing engines have been actually talking about, well, they also use tiles, but they have a different use case and different data stored in those tiles, even though the fundamentals of chopping up the world into pieces is more or less the same. So if they have the routing matrix in their data as a separate layer connected to the geometry, so not only can they route offline, but also can visualize whatever they routed, that would be convenient, you know, multiple layers. One layer describes geometry, the other one describes connectivity graph, and bam, you have offline routing and visualization in the same stack. And, well, the usual engineering tasks of make it faster and smaller. So another fun little thing, geometry clipping. We're so focused on, well, each tile should be separate and not touch anything else, and maybe have some overflow on the edges just for the rendering purposes. But in reality, in many use cases, if the geometry usually spans just a few tiles, and stitching the geometries is painful and complicated, why not just store geometry in one tile, and the neighboring tiles that are in the same bounding box would just reference it. You know, the center one has the geometry, and the one in the upper right corner has that this geometry exists, but you have to go -1 x-wise and down 1 y-wise on the y-axis, and you'll get to the geometry. In many use cases, this works just as well. And you just store bounding box inside the tile to indicate the size. So you can quickly say, oh, I'm interested in loading this geometry, or actually, I might not even care about this geometry because I'm currently processing different data types, or I'm not in that part of the tile. There's new Martin MB Tiles tool, something that I have been hacking on actively with help of others, and that's a tool to handle MB tiles better. Copy tiles from one MB tile to another, merge that, add some hashing to it, be able to validate an MB tiles file, be able to have like predictable content that if you ship it, and imagine you're using it in a vehicle and you don't want your vehicle to blue screen, you want to validate the data, and it's kind of useful to have hashes all over the place. So that's now MB Tiles tool is trying to normalize and standardize all that. And another very nice feature of MB Tiles tool is you can actually create deltas between two different MB tiles and ship just a delta and have a standard way of applying that delta on the other side. Again, offline use cases with connectivity once in a while. So now that brings it to the most important thing. There's this effort by Marcus in Germany, who's a researcher who's been trying to come up with a better vector tile format itself, fundamentally change it. And he's been able to achieve 5 times reduction in MVT size. Oh my God, you can do that? Data can be compressed better? Who would have thought? And it's 2.5 times faster to parse. Again, because you don't have to make multiple copies of the data while you're parsing it. It was inspired by NVT and GeoArrow and many other standards like Parquet. And yet it follows the same concept of a layer/feature breakdown, but at the same time, it's no longer rows. Each individual feature is a separate row. Instead, it's a column-based store with all sorts of encoding options where you can do delta encoding and optimize it, and you can optimize it for. Now I'm like thinking how a SIMD is decoded, but basically operation, same mathematical operation in multiple data points. That CPUs, all CPUs nowadays support natively quite well. So, interesting thing is, we are in a position to actually touch all these different points of the stack. We can talk to Postgres people. We love them. We know them. We can work together with them to add functionality to Postgres, for example, or add more functionality to Postgres itself as a new plugin to generate the tiles. We can modify the data serving stack to add capabilities of supporting additional tile formats. We can change the Map Libre to do rendering changes. So all of these pieces can be rolled out all at once. So we just need to agree on something. I know it's almost impossible, but still, I have high hopes that we can actually roll out new vector format to move forward. And that's maplibre.org. And we have a huge community, and most of it is on Slack. And then there's a lot of discussion on my personal GitHub about the future of MVT. So I highly recommend going there. And I am done, and I have time for questions. Thank you very much.